Okay, hi everybody. I am afraid. Thanks very much. I'm still suffering the effects of last night, so please bear with me. And please excuse this climate. Okay. Well, I think this is true. Okay, so let's start with talking about the Windows and XenApp LogonProcess. I think it's better to have that closed, even though it's not good for the temperature. So, in case you want to follow me on Twitter, there's my Twitter handle. I'm very happy to have received these 3 community awards, CDP, MVP, and the expert as of late. You might have used some of my tools. There are 2, XenApp has been around for about 14 years now. The current tool of choice is of course UberAgent, which is a monitoring product for Windows based on the Splunk platform. And some of you, or maybe even a lot of you, may be using Citrix Program Management, which is basically the successor to Okay. Now, during this session, I present all kinds of numbers and figures. All of these were collected on the latest and greatest Microsoft and Citrix platforms, 2012 R2 with XenApp 7.6 installed. Very important thing is all of the tests which I conducted were run in a steady state. In other words, the machine was booted up, all the DLLs were in RAM, and it was not the first logon, but the second, third, and so on and so on and so on. If you measure anything, ignore the first measurement. It's always incorrect. Well, not always, but in many cases. The tools used were, of course, our own UberAgent, always the great process monitor, and also Wireshark to collect the network trace. You'll see how that fits together in slide 2. Okay, and now let's start with the actual logon. When you think or read about the user logon, sometimes you see depictions like this. So first, if it is an ICA connection, of course that connection needs to be established. Then Windows sets up its the user session. Then at some point in time, the profile is loaded, group policy is being processed, Logon scripts are executed, and then finally the shell is started. Looks clean, nice, and easy. The only thing that's wrong with this graph is that it is, this is fairy tale land. It has nothing to do with reality. In reality, it looks a little bit more like this. This is taken from an UberAgent dashboard, and you can see all these dozens of processes that are running. Some of them are run concurrently, some are run one after another. So in other words, some things that happen here are synchronous, others are asynchronous, and all together, all of that taken together is extremely complex. Anyone telling you that logons are not complex, that logons are easy, they don't know shit. So. UberAgent, for example, it gives you a total logon duration. That might be 20 seconds. Then it gives you the duration of a few phases, let's say the loading of the user profile and processing of group policy. A very popular question I get is, if I add up the various phases, I don't get the total time. Yes, of course you don't, because there's so much shit happening that there's just no name or you can't just put a tag on everything. The only thing you can do is pick the most interesting things and put a name, put a handle on those, and basically that's it. Now, what we're going to do in the next half hour or so, we're going to look at one single logon in great detail, possibly too much detail, but you'll be the judge of that. I recorded this one single logon with 4 different tools, with Process Monitor to find out what the applications what the file and registry activity was, Wireshark to find out what was going on over the network. Then I looked at the Citrix broker log file, which can be enabled by following the instructions in this CMDexe article. The log is quite interesting, by the way, after once you figured out how to read it, and then of course Uber Agent, which shows all kinds of interesting data too. So without further ado, let's start with this analysis. The very first thing that happens when you click a link in Storefront is this beautiful gray screen. So looking at what's happening here from various angles, the first thing you can see is that something's happening on the network. The DDC is talking to the VDA. So obviously, that connection goes both ways. So the DDC can contact the VDA, and it works the other way around too, as we'll see a little bit later. Then there's an interesting process that's being started more or less at the very beginning of the session setup. That's this SC Service 64. And as we can see in the process monitor trace, this executable loads an agent, loads a DLL called agent2stack DLL, which is an interesting name. So let's take a look at what's happening here a little bit more detail. When you look at the communication between the DDC and the VDA, well, you can only do that with a network trace. You'll see that the type of communication is HTTP, and the data being transferred is XML data. So it's text, and then it can be easily read, but well, understanding it is a different matter, because most of that I'm showing here is not documented at all. So I'm taking clever guesses, and some of them are hopefully correct, and others might be wrong. In any case, all of these communications, whenever the DDC wants to talk to the VDA or the other way around, there are four, not packets, but four actions, one after another. First action is this RSD issue, then SCT, whatever that means. So apparently some kind of trust relationship is being set up. Then the actual action is being executed. We'll see a few of those. And then this whole the connection is being cancelled or torn down. In the previous slide, we could see that the actual action was prepare session. So that was the what goes on the third line of this communications pattern. Okay, the other thing we noticed on the earlier table was that SC Service 64, that's the Citrix stack control service, and what it exactly does can only be guessed, because Citrix is very good at not documenting it. Anyway, what I could find out that it's kind of an interface between the broker agent and the actual ICA stack. Those two need to talk a lot, and they do that through this helper service. Now, as the connection is being established, time passes, and we're already at 1 second and here at 3 seconds into the logon, and not much has happened yet. As we can see here at 1.2 seconds into the logon, terminal services loads a Citrix DLL. That's interesting, isn't it? RPM DLL, that's Citrix Remote Protocol Manager. Now, why would a Microsoft component, terminal services, load a Citrix component? Well, the answer to that is that Citrix changes the way Windows operates quite a bit. It does that through hooking, and let's talk a little bit about what that hooking is. Most of you will probably have heard the term API hooking. But I hope at least not everybody of you knows what it is, otherwise I should be skipping the next few slides. So normally when an application needs the operating system to do something, the application loads a certain DLL, any of the many DLLs Windows ships with, and then once the DLL is loaded, the application calls a certain function in that DLL. In this case, the function is creatively named do something. So that's the regular way that things are going normally. Now with API hooking in place, the hook it changes what the application is doing. The application thinks it's calling this do something function in the Windows DLL, but in reality, the application is calling a hook function in this case, in the Citrix DLL. So it's like I want to talk to someone at the back, and I'm talking to you, and without noticing that it's not the guy in the back. So, and you here in front, you can of course do anything with my message. You can just drop it, you can change it, you can do whatever you want. So you can totally change the way things are working. So API hooking is extremely powerful and extremely dangerous too, because if these guys here fuck up, everything is fine. The Citrix API hooking mechanism works like this. Windows has a functionality, it's called AppInit, by the name of the registry value that controls it. And if you place the name of your component, of your DLL in that AppInit registry value, your DLL gets loaded into every single Windows process, which is, of course, extremely powerful, because once you are in a process, you can control that process. You can do whatever you want. For example, you can install your own hooks, or do other bad things. So Microsoft has promised, threatened, whatever you want to call that, to disable this AppInit mechanism because of the grave nature of the things that can potentially be done. But as there is really no alternative, and if you really need to change the way things are working on Windows, you have no alternative other than even worse things. And so Microsoft, they always announced they're going to disable it, but it still works in Server 2012 R2 and very likely in Windows 10.
It will be possible to change DLL.
You can of course change.
I mean, you give your DLL the name of the DLL when you want to hook on, and then you work with that. Can you do this?
No, you can't do that, because if the application is well written, it'll look in the correct directory first. And if you place your own directory named as the original DLL, but in a different directory, it will not be loaded. Or even if you place it in the Windows directory, for example, the load order will be. It should be like that the load order is incorrect, that not your DLL gets loaded. But that's a creative approach, yes. So, one thing you can do is you can turn off all of this API hooking, but you'll find that basically XenApp breaks when you do that. Nothing works anymore. So, that is a bit extreme. But the way the Citrix hooking mechanism works, you can see MF, I always love these old acronyms, MetaFrame of course. This generic Citrix hook, it reads, it doesn't do anything itself, but it reads a list from the registry that is stored here, HKLogin software Citrix, and so on and so on. And all the DLLs listed there are then loaded into the various processes that are running. And as it says there, some of the Citrix hooks are loaded into all processes, some are only into specific processes. And here's a complete table of all the DLLs listed there. You can see some, what I mentioned, some of the hooks are loaded into all the processes. These are supposed to be asterisks. So these are all, and hooks like, for example, Explorer hook, as the name indicates, is only loaded into the Windows Explorer. And others are loaded into the spooler, the printer spooler, and so on and so on. There's a difference between the hooks that are loaded into 64-bit processes, those are listed here, and the hooks loaded into 32-bit processes. And I'm very much aware of the fact that you can't process this table right now in its entirety. I'm going to block all of this, explain it in more detail, and put it on the net so Google finds it, and hopefully that will be helpful to you or to other people. Now, you can, I'm a bit irritated by the moving, thing here. I hope it's okay, you can still read it. Well, you can change the way that Citrix hooking works. One of those was mentioned earlier is disabling AppInit DLLs, probably a bit extreme. You can disable all of these hooks individually that were listed earlier. Or you can, if you have a problem with a specific application, then you can disable the hooks for that executable only, and that's described in this CTX 107825 article. That might be a good idea to try. If an app is behaving strangely on Citrix, but not on a workstation, for example, then try to disable the hooks, see if it changes anything, and if yes, then you need to analyze that further. Okay, now continuing with that interesting little Logon analysis. We're already at about 3.5 seconds into the logon when the broker agent on the machine the user is connecting to gets the client name and then checks the Citrix license. It does that by talking, but in this case the other way around. The DDA is now talking to the DDC. It sends a validate message, and if that doesn't work out, then the connection is over pretty quickly. But typically it should. Typically it works, of course. Then a little bit later, the broker figures out if the session is going to be a desktop session or an application, a published application session, and it figures out, okay, this seems to be an ICA connection. So, okay, so let's move on.
See a very nice function to place a hook in this slide.
Decrypt password. Yes, I can't really explain what it's going to be, what this means, but well, decrypt password is kind of self-explanatory. And I found it so interesting that I put it here, so yes. It's there's a lot of interesting stuff going on. Then I picked those functions that I thought might be of interest.
So this probably takes the password that's in the ICA file or the hash thing.
Could be.
Yeah. Okay, understood.
Now, the 3.5 seconds have passed, and what's happened? Well, not much. The broker has talked to the VDA has talked to the DDC and done a little bit of stuff, but that was it. At 3.5 seconds, the Windows session is being created, only at 3.5 seconds. Before that, there was no session on the server, not for this user at least. And with every session that is being started, a few of the basic Windows processes are started, like you've probably seen them many times in Task Manager, for example, with SMSX, CSRS, Winlogon, and so on and so on. And we saw that DLL, that terminal services loaded very early on, RPM DLL. This is still active. It's still doing all kinds of things. So that's one of the many, many examples of things that are running in parallel. And let's take a look at all these processes that are running in a little bit more detail. The thing to note is that we're still seeing that gray screen. For the user, nothing has happened, except that this spinning thing, whatever that is, moved a little bit. Now, a few words about those processes. The first process that is started for every single Windows session is SMSX. Actually, it's not even a Win32 application, it's a native application. So in other words, it can't access the Win32 API, which might be of remote interest to some developer guys like myself and possibly Repco. Then this SMSX starts CSRS, and that is the executability that makes Windows Windows. So it basically provides the Win32 API and a few other things that actually enable typical console or graphical applications, windowing applications to run. Then finally, the third process that is started is Winlogon, and those of you that remember the good old days, they may remember that back up to and including server 2003, Winlogon loaded something called Gina. That was a DLL that was responsible for displaying the graphical user interface for typing in the password and well, basically interacting with the user during the logon. Well, as the Gina was a DLL, it was loaded into the Winlogon process, and sometimes other companies like Novell and possibly Citrix and a few others, they created their own GNAs. It started to get funny when you had to do something like GNA chaining, when you had a novel authentication and, so a novel GNA and, let's say, a Citrix GNA, and those had to be installed in the right order or things would break. But the really bad thing about GNAs is, since they are DLLs, if they crash the Winlogon process. And since the Winlogon process is a critical Windows process, that basically crashes Windows. Microsoft noticed that, and of course, and they wanted to move the blame away from themselves, which is only logical, because if Winlogon is crashing, everybody says Windows is bad, Windows is buggy, and so on and so on. But if some, let's say, novel.exe is crashing, everybody says Novell is bad. And Microsoft wanted it to be that way. So they decoupled this and moved all that user interaction thingy in the Logon UI process, which was introduced with this stuff. And Winlogon keeps doing all the backend, the important stuff. Now, continue with the Logon. In about 4.5 seconds in, the ICA connection is being established. And a little bit later, we get a video connection. That means we've gone from the gray screen to the black screen. Big improvement. For the user, in my opinion, this totally sucks, this UI. Citrix should be doing it much better. So I need to be a little bit quick because I have some pretty cool stuff I want to show you after all this, so I need to cover it a little bit. So now that the user is actually logged on, there are two notification mechanisms that are kicking in, and I want to talk about those briefly. One of those is this MPNotify thing. It notifies all registered network providers. All of these, they are listed here, all of these get the password in clear text. That's also very interesting. So Remco, in this case, they don't even have to decrypt something, they just get it on a silver tablet. And why do they need it? Well, of course, if the user needs to be logged onto a backend service, like whatever, a Windows network file server, SMB file server, at some point in time, the password needs to be passed through that backend machine. Or possibly with Kerberos, it could be done differently, but there's still that way of doing that option to do it like that in Windows.
So if you want to see plain text passwords without all of this, download a tool called Mimikatz. It will show you all passwords, services, system accounts, connected users, SMB, clear text, instantly.
Yeah.
Boom.
I've heard of Mimikatz, I've never used it, but apparently it's an extremely powerful tool, yes. Okay, so this is one of the notification mechanisms. We'll see another one a little bit later. And now, only about 7 seconds into the logon, we see familiar stuff happening. This is the cool, the good stuff. We Citrix guys, we talk about and analyze that to death. That's like Citrix profile management is called. It's of course it does its thing. Then the home directory is mapped, which is interestingly, well at least I find that interesting. It's done by the internal services service. Then all that group policy processing starts, and at this point, a second notification mechanism kicks in. This is the only synchronous notification mechanism, and that is extremely important to you if you decide to write a better profile management product, which I did a while ago. So, there are many notification mechanisms that your app can subscribe to, and then you'll see new logons coming in, and so on and so on. But all of those are asynchronous. In other words, the system doesn't wait for you to do something. It just tells you, user logging on, and I'm moving on, and it's too late. So this one is synchronous. So Citrix Profile Management uses it, as do a few other, as does the original Windows profile service that needs time too, of course, to prepare the user profile. The group policy client does it because group policy obviously needs to be fully processed before the logon can proceed, and a few other things.
I always wondered how you did that.
Sorry?
I always wondered how you did that.
Okay,
There
so
you go.
basically that's take a good look at what's here and how Citrix buffer management is embodied there, embedded or whatever. Okay, the Citrix buffer management, as I indicated, it needs to be notified synchronously, so others need to, the Logon needs to be stopped while it does its thing, and it needs to be notified before the Windows profile, user profile service. Because the way Citrix buffer management works, if the user has a profile on some, in the data store, on some location on the network, Citrix buffer management brings in that profile, puts it on the local disk, and leaves it like a local profile. And when it is done, the Windows user profile service, when it becomes active a little bit later, it says, wow, this user already has a local profile, I've got nothing to do. This is cool. So I can go back to sleep. And of course, after that group policy is being applied, and at Synergy and Bifrom, I had an entire session about the group policy processing, which is kind of interesting too. Let me try to sum it up in about 5 sentences. Group policy is modular. It contains the modules are called CSEs, client-side extensions. Those are these things here. And all of these CSEs that are being used, for example, one is for mapping folders, the other is for setting registry values, and so on and so on. They're called synchronously, one after the other, in a specific order, but that order is not documented. So it always starts with the registry values, administrative polity, administrative what are they called? Settings, templates. Yes, thank you. Those are applied first, but then it's a specific order. All of these CSVs one after another. So if you're wondering when you're mapping a drive, for example, and you're setting an environment variable, just to take two, there is an order, and it's always the same. So it is guaranteed to be the same. But if the order is wrong for you, if you want it to be the other way around, forget it. As one of these CSEs is the Citrix CSE client DLL, and that DLL it's basically a pretty lazy guy. It just notifies a service Citrix installs, the Citrix Group Policy Engine service, and then that CSE goes back to sleep. So this service does all the important thing for Citrix. It combines. You can configure Citrix policy settings either in the farm or in Active Directory, and yes, it is supported to use both, but it gets confusing, so don't do it. In any case, the Citrix Group Policy Engine service, it combines anything that might be configured in the farm and in Active Directory, it applies that, and it creates the RSOP data. And by the way, if you configure the same setting in the farm and in Active Directory, the farm loses. Active Directory roots, which might be a nice quote. Okay, and then basically after this has happened, the shell is started through user init, and the logon is more or less finished. I need to hurry up a little bit, so please excuse me not going into all this in detail. One little bit detail on this user init process. This Winlogon / user init registry value, and normally this just contains the path to this executable system32 user init.exe, but you see there's a comma, and you can, well, anybody more or less can add additional processes, and all of those would be executed as part of the user logon, which is a nice way to integrate your specific app or whatever you might be creating into the logon, but it doesn't seem to be that popular anymore, but still working, of course. And this is the way user init.exe is called, and user init does as part of the thing that it does. It used to run application compatibility scripts. Some of you may remember those. I was about this old and this big when they were on vogue. Anyway, those are still present, and those are still being executed for every single logon, unless you specifically manually disable that. That is part of the USR logon.cmd. And you basically can delete that from the registry unless you have some really old, really crappy applications that depend on specific environment variables being present. Because this still sets a few environment variables, and if you don't have those applications that were written about 55 years ago might stop working. So, but
You
when
don't
you
need a root drive or something.
yes, wow, good memory. Root drive is part of that. Yes. When you install XenApp, it adds the cmstart.exe executable, and that is basically responsible for starting WF shell, which is the Citrix seamless Windows engine. If that doesn't run for some reason, seamless your published applications might look a little bit funny. This WF shell executable, it loads. It reads a list of virtual channels from this location in the registry and loads for each of those, well, there's a list of DLLs and it loads all those DLLs, and each of those DLLs is responsible for implementing a specific virtual channel. And apparently it happens from time to time that, for example, the clipboard virtual channel stops working, that Ctrl-C, Ctrl-V from local to the remote session doesn't work. Apparently the reason for that is, in many cases, that simply the entry for this one specific virtual channel is missing from the registry. However, that came about, but many people have been complaining about issues on some forum or some part of the internet. Okay. So just that was basically this big walkthrough, the boring part. I hope the other stuff is even more sexy. So let's take a look at a specific example. Some of you might have seen that on my blog already. While researching the data for this session, I found that there's a strange delay, and that his black screen phase was a little bit too long. So in Uber Agent, it looked like this. So there's a long gap here before user init is being started. So during that time frame, more or less nothing's happening. At that time frame, the duration of that gap is about 10 seconds. And this looks like this to the end user, this super sexy user interface. And this is taking way too long. Now this 10 seconds of black screen.
Like branding Internet Explorer DLLs or something.
That would be a good guess, but no, not quite. So then finally we get the desktop. Okay, but this black screen is quite annoying, and it shouldn't take about 10 seconds. So I tried to find out what was happening, and I analyzed it left and right, and I even disabled IPv6 because I suspected there might be some networking issue or something in my lab, but that wasn't the case. Everything was working correctly. I even installed a fresh server, a new server from scratch, and it also had that issue. As it turned out a little bit later, there's a bug in one of the many Citrix DLLs that that more or less hook into this Logon process, and Citrix has a more or less secret hotfix that fixes it. So if you experience this issue, try to get your hands on this CMDexe thing 14.20.36. When I blogged about it, quite a few people were interested because they noticed they had the same issue in some cases without even noticing it was a bug. And while this was happening on XenApp, someone told me, one of the Barry Schiffer, one of the other CTPs, told me that he was seeing something similar with XenDesktop. Unfortunately, this hotfix here is only for XenApp. So what goes? So as he found out a little while later, there's a different hotfix, in this case for the workstation, for XenDesktop, and this bug causes a 60-second delay if the keyboard layout is different between the client connecting and the machine the client is connecting to. And this one of those fine examples where American developers test. They test with US English and US English and US English and US time zones.
Really?
Works perfectly. Well, it's good to roll out to the world. So, yeah, that sucks of course.
So interestingly, this hotfix, judging from the title, is for 7.6 only.
Yes,
But it would
I
be
think so.
quite likely that this issue exists in 7.5,
7.1,
7.1, 7.0. Thereby forcing you to do this upgrade, which we all know in large enterprises is difficult because you know you need to go through change process.
You can of course ask Citrix to port that fix to ZenApp, to ZenDesktop 7.5 or whatever you might.
You can ask them anything.
It might take only a year or two or so.
Limited time.
Okay, so those were these delayed examples. Well, there's another one actually coming up. Another thing I noticed when I looked at these logons is that the green thing here, that's Explorer. So Explorer is being started at this point in time that the first red line shows. And then typically Explorer loads many child processes. All these little things that live in the taskbar, these tools next to the time. All these little things are started by Explorer as part of the Logon process. And normally, Explorer initialization takes maybe half a second or so, and after that half second, Explorer loads all those little things that you have installed. But in this case, Explorer loads the first child process after about 13 seconds. I found that strange. And it also means that things like, and if you have Citrix receiver installed, it will also only come up after about 13 seconds, so it does affect the end user. And I looked left and right for explanation of what might actually be happening during those about 13 seconds, and I found in Process Explorer that the Windows Explorer is creating lots of disk I/O, and most of that disk I/O goes to this one directory. This one, it's in the user profile, app data local, packages, and then something immersive control panel. And the process monitor, by the way, has this amazing view that you can bring up that shows you per directory how much disk I/O there is, and that can be really helpful in finding out where's the most action happening. So in this case, it turns out that Explorer creates about 600 XML files in that directory. For every single logon, because that's an app data local, it's not roamed. And that takes about 13 seconds. I found no explanation of why this is happening. Yeah.
Are you redirecting app data? There is a
No, absolutely not. I read it.
I just saw 2 backslashes.
No, there was nothing redirected in this logon. It was a standard, super boring, simple local logon. So I have to hurry a little bit because I have one very cool thing to show you at the end. So Explorer creates these 600 files. Nobody knows what they're for, but they are recreated every single time. So I thought, now I'm clever, I'm going to trick Explorer. I'm using Citrix Profile Management and I'm including that folder. So it is roamed, no problem with Profile Management, but it didn't help. Explorer ignored the files that were sitting on the disk and it wanted to create them from scratch. So I have no solution for this, but it seems to be in general affecting every Server 2012 R2 installation. If you want to, if you have the time, verify that it's happening in your environment, and please let me know if it is the case, yes or no.
What was in the files?
Those XML files, I don't know what their purpose actually is, but when you go to that directory, in your own user profile, you have it on Windows 8.1 too, so it's not only on the server. When you double-click one of those files, you can bring up, by double-clicking each of those files, you can bring up all the control panel pages and dialogues individually.
So, immersive is the way Windows allows you to adjust whatever is in the view. So you can actually change the way control panel appears, what applets you see. Probably there's some logic that you can, as a user, change this. Therefore, they're pushing.
Well, there are no actual settings in those files. I looked at a few of those. they doesn't look too interesting what is stored in there. No. Good, okay, so in the last few minutes, there's one little thing I took a good look at. And PowerShell is all the rage these days. Well, you can do great things with PowerShell, of course. And so some people are using PowerShell for Logon scripts. Now, question. Who of you thinks that it is a good idea to use PowerShell for Logon scripts?
It's a trick question.
One.
Yeah, of course.
Okay, who of you thinks it doesn't matter whether you, from a performance standpoint, whether you use PowerShell or Batch or whatever? Depends. Depends. So, okay, all the others didn't dare putting up their hands, so you're ready for what's coming. So, I took, I tried to measure the effect of PowerShell in a steady state. So, in these experiments, all the .NET DLLs and everything PowerShell and the other scripting languages need, it's already in memory. There's a XenApp, the machine is booted up, the first logon was ignored, and so on and so on. All of these things are super important if you want to get reliable numbers. Now, to compare the resource utilization or the footprint of the actual scripting language, I didn't want a complex script. I wanted something as simple as possible. Basically, I created a one-liner in all of these languages in order to measure the language overhead. Now, in Batch, it's like this. It just writes the name of the user into a temporary file. We can do the same in PowerShell in a one-liner too. And we can also write the same code up, the same functionality in about 2 million lines of VB script. All of these do the same, and they're super simple. Now, let's take a look at how long these scripts execute during the user logon. So the big one, that is PowerShell.
45 seconds?
These are milliseconds, so 4,500 milliseconds, 4.5 seconds, and the other a few hundred milliseconds. So I ran this test several times. These are averages. There is not one single logon. Yes?
So overall it doesn't matter in the logon process, right?
Well, delaying the logon by 4.5 seconds is kind of not cool.
Yeah.
Now let's look at the performance, at the resource utilization. First, CPU usage. These are CPU seconds. So actual CPU time that this script eats and never gives back. So PowerShell is a little bit less efficient than the other two. Let's look at RAM utilization. The PowerShell script needs about 100 megabytes of RAM, and while the others are at 20, 25. And finally, disk I/O. The other two, all the DLLs were already in memory. That means these generate no disk I/O at all, and PowerShell generates about 8 I/Os, which is not that much. It's not really bad, but the difference is quite interesting. So the only conclusion I can draw from that is it's a really, really stupid idea to use PowerShell in Logon scripts. So with that, thanks very much for your time. Have a great evening.